Hello students, welcome to MemoNeet. I am Aprajita, your chemistry SME. How are you all doing? I hope your preparation is going well. So as you know, we are going to appear for BPT 6 very soon, right? And I hope you have completed your electrochemistry revision. So in the last video, I discussed the PYQs, the important PYQs from each topic of electrochemistry, so that you can get an idea about what kind of questions are asked in the exam and how to solve those questions. So if in case anybody has not watched that video yet, please go and watch that and try to understand how to solve the numericals. Okay. So today I am taking another chapter. So you know that BPT 6 is your cumulative test in which all the chapters are coming, whatever you have been whatever chapters have been asked in BPT 1 to 5. Okay, so there are total 5 chapters which we will be revising using questions. Okay, so I am taking questions and along with that I will make you understand or revise the concept of that particular question as well. Okay, so today I am taking the chapter which is structure of atom. So we will be doing the revision along with solving the PYQ so that you can get an idea which topic to study, how to study, and what kind of questions you can expect in the exam, right? So what are the topics that we have studied in this chapter, students? Firstly, we talked about the discovery of the subatomic particles, right? Whatever subatomic particles are there, we have talked about that. After that, we studied various atomic models, right? Thomson model, Rutherford's model, then Bohr's atomic model. Before Bohr's atomic model, we discussed what were the developments that led to the Bohr's atomic model, right? Like the dual nature of matter. We studied the dual nature of matter also, dual nature of particles as well, right? The wave nature and the particle nature. So we discussed the electromagnetic spectra also. Okay, then we studied the Bohr's atomic model, how he discussed the spectra of hydrogen, the atomic spectra of hydrogen. But then there were still some things that were not resolved by Bohr's atomic model as well. So it could not explain, according to the Heisenberg uncertainty principle, various things were there. Okay, photoelectric effect. So in that case, we got the quantum mechanical model of the atom. So at the end, quantum mechanical model is the one which we are using, okay, which is talking about the quantum numbers. So we discussed what are the 4 quantum numbers we have, how we get the information about any electron or any atom from the quantum numbers, right? So all these are the topics, important topics of this chapter, and we will be learning revising the topics today along with discussing the PYQs. Okay, so I have my first PYQ here with me. Okay, so the question is here, students. It says select the correct statement, okay, from the following. This question has been asked in NEET 2023 and it is direct from your NCERT lines, okay. So 5 statements are given. Atoms of all elements are composed of 2 fundamental particles. Mass of electron is this much, 9.10939 into 10 to the power minus 31 kg. All isotopes of given element show same chemical properties. Protons and electrons are called nucleons. Dalton's theory regarded the atom as ultimate particle of matter. So what you can think of this question ki yahan par it's a very basic question. It has been asked from the very basic concept, okay, but to solve this question you need to know everything, all you need to have the information about all the 5 statements, okay. So if I talk about the fundamental particles, students, so you know here you can see that we have actually 3 subatomic particles, okay, 3 subatomic particles. Electrons, which are negatively charged, protons, which are positively charged, and neutrons are your neutral particles which have no charge. Okay, so these are the masses given here. So if I talk about the relative mass, so for proton and neutron it's approximately equal, so we take it around 1, which is equal to the mass of hydrogen atom, okay, but the mass of electron is very less. So mass of electron is 9.109 into 10 to the power minus 31 kilograms, okay. This is the mass given in AMU. You can see again for AMU, this is the mass that we take in our calculations in atomic mass unit. So neutrons and protons have approximately equal masses, but electrons have negligible mass as compared to them. Charge, so the magnitude of charge is same, 1.6 into 10 to the power minus 19 coulomb, but the charge on electron is minus 1, minus we take it as -1, okay, and in general we for protons we take it as +1, and for neutrons it's 0. All right, so let's see the question here. Atoms are composed of two fundamental particles. This is wrong because there are three fundamental particles: electrons, protons and neutrons. Mass of electron is 9.109, yes, into 10 to the power minus 31 kilograms. This is correct. All the isotopes show same chemical property. Now, what are isotopes, first of all? So, students, isotopes are actually the atoms of same element, okay, which have same atomic number but different mass number. So if the atomic number is same and the mass number is different, we call them as isotopes. Like if I talk about hydrogen, it has 3 isotopes. So hydrogen has atomic number 1, but the mass number is 1, 2, 3. Now students, we have studied that atomic number is equal to the number of protons as well as the electrons, because for a neutral atom they are equal. So it means that if the atomic number is same, then all of them are having same number of electrons. Isotope में, although the mass number is different because there are different number of neutrons. Okay, there are different number of neutrons in that particular isotopes, but the electrons and protons are same. So the chemical property of an element, it depends on the number of electrons, because electrons are the ones that are going to take part in the chemical bonding, right? So it means that if they have same number of electrons, they will be showing same chemical properties. So this is also true. And now if I talk about the atom, so protons plus the neutrons, they are present in the nucleus of the atom. They are you can say they are the one which comprises the which makes the nucleus. So protons and neutrons को हम बोलते हैं nucleons. So it's not electrons, it is neutrons. So this is also wrong. Dalton's theory. So yes, Dalton was the one who gave us some postulates in the starting, and yes, he regarded the atom as ultimate particle of matter. He said all the matter around us is made up of atom. So this is true. So what I can see, that second statement is true, third is true and fifth is true. So the answer is going to be option C. Okay, so this is how we are going to solve any question. You can note this flow chart as well. Here all the information about the mass and charge of the subatomic particles is given. So you need to know the masses also in AMUs, in kgs, and the charge as well. Okay. And you need to know about the isotopes and isobars as well. So isotopes have same atomic number, different mass number. Let me tell you about isobars also. So they have same mass number but different atomic numbers. Okay, so that's the thing in this case. For example, argon and calcium, they both have mass number 40 but their atomic numbers are different. Okay, so that's the case in this particular thing. Alright, so now we'll be moving to the next question that I have taken. So the next question is the number of protons, neutrons and electrons in, this is Lu, Lu is lutetium. 71 is given, 175 is given. So I need to tell the number of protons, neutrons and electrons. But for that you need to know ki what is the meaning of this particular representation. What is 71 representing to me and what is 175? If I don't know, I can't solve this question, right? So we need to know, students, ki how we are representing any element. So have a look here, students. Here I have given you the representation. So the symbol of the element is written in the center. Okay, X represents the symbol of the element. Then A is the mass number which is written in the superscript, and Z is the atomic number which is written in the subscript. So it means that for lutetium, the atomic number which is given 71 and the mass number A is given 175. Now you need to know about the relationship. So if I talk about the atomic number which is Z, so I'm writing in short only, it is equal to the number of protons present in the atom. Okay, and for a neutral atom the number of protons and electrons are equal. And if I talk about the mass number, so mass number is the number, or you can say the sum of number of protons and the neutrons. Okay, so it means that the number of protons and electrons are both 71 and the number of neutrons that we can calculate 175. If I subtract 71 from it, I will get the number of neutrons. Okay, means I will be getting 104. So they have asked about protons, which is 71, neutrons, which is 104, and electrons again 71. So the answer is option D. See, again a very simple question, but you need to have the knowledge of the concept. Okay, so this chapter is an important chapter. It carries great weightage also, but yeah, you need to study the concepts in detail. All right. So this is the next question. So try to guess it, that from which topic this question is being asked. Okay, it says when electromagnetic radiation of wavelength 300 nanometer falls on the surface of sodium, electrons are emitted with a kinetic energy of 1.68 into 10 to the power 5 joule per mole. What is the minimum energy needed to remove an electron from the sodium? Now can you guess it, students, that this question has been asked from the photoelectric effect. Okay, now see, there is nothing written as such photoelectric effect. But if you know what is photoelectric effect, then you can easily solve this question, right? Ki ha, this question has been asked from there and we will be using that particular formula. Okay. So students, you know ki whenever in photoelectric effect, what happens whenever a light of a suitable frequency it strikes the surface of a metal, electrons are emitted, and electrons are emitted with certain kinetic energy. Okay, so here this is the energy of the light wave that is being put, but in this question whatever is given to us we will be writing that. So try to understand this. They are saying that electromagnetic radiation of wavelength 300 nanometers. So this radiation is being put on the metal, okay, which is 300 nanometers. So 300 into 10 to the power minus 9 meter I can write, and electron is emitted with the energy. So kinetic energy is given, students, 1.68 into 10 to the power 5 joule per mole. Joule per mole means this is the energy emitted when 1 mole of electrons are emitted. Okay, so that's the energy for 1 mole of electron, not just one. And you know that there is a certain minimum energy required to remove the electron, okay, which we call as work function. So that we have to find out. Okay, so what is the formula here is that if the wave of energy h nu is strike on the metal surface, okay, so there is certain minimum energy required, which is h nu naught plus, which is and rest is the kinetic energy. So rest energy goes to the kinetic energy of the electron. So you can write here that E is the energy of that electromagnetic radiation. E minimum is the minimum energy required plus sorry, it's not half, okay, half mv square I was about to write. So that is the kinetic energy. Okay, so I have to calculate E minimum from here. E is, and it will be minus kinetic energy. Okay, so this is what we will be doing in this case. But the thing is that we are not given the energy of the incident wave, we are given the wavelength. So how to find out the energy in that particular case? So students, you know that the energy of any wave will be given by h nu, and since nu will be c upon lambda, right? So I can write it as hc upon lambda, where h is the Planck constant, 6.626 into 10 to the power minus 34. C is the speed of light, 3 into 10 to the power 8 meter per second, divided by lambda, which is the wavelength given to us. So when we will calculate it, I will certainly get the value for the energy. Okay, that is the energy of the incident electromagnetic radiation. So it will come out to be 6.626 into 10 to the power minus 19 joule. Okay, now this is the energy that is there. Now the kinetic energy. So I have to calculate the minimum energy to remove one electron. Okay, and the kinetic energy, students, that is given to us is 1.68 into 10 to the power 5 joule per mole, means it is for 1 mole of electron. So if I need to find out the kinetic energy of 1 electron, okay, so I'll be dividing this kinetic energy with the Avogadro's number, okay, 6.022 into 10 to the power 23. 3. So we will be subtracting, dividing this value here. Alright, then you will be getting the energy, kinetic energy for 1 electron. Okay, then you can subtract this value. You can solve it here also. 2.79 into 10 to the power minus 19 joule. Now the energy is in joule. It's not joule per mole. It's joule because it's for 1 electron. Now you can clearly find out the minimum energy. Okay, so minimum energy is E minus kinetic energy. So E I have calculated 6.626 into 10 to the power minus 19 minus 2.79 into 10 to the power minus 19. Now you can see the units are also same, just need to subtract. It will come out to be 3.84, okay, into 10 to the power minus 19 joule. So this is the energy that is required, minimum energy required to remove an electron from the sodium metal. So joule per mole, that is the case. So this will be the answer. Okay. Alright students, so this is the energy for 1 electron that we have calculated. So see, this is how the knowledge. Now if we don't have the knowledge of this equation, that is the photoelectric effect, we cannot solve this question. So that is why knowing the concept and knowing the formulas are very important. That's why I asked you to go through the points to ponder on the MemoNeet app. Okay, there you will find all this stuff. Fine. So I hope this question is pretty clear to everyone how to solve this question. Now we will be moving ahead to the next one. So students, this is the next question. Here you can see that the question says which of the following series of transition in the spectrum of hydrogen atom fall in the visible region, that is Lyman series, Balmer, Paschen and Brackett. So you know about the line spectra of hydrogen, right? So to answer this question we must know about the line spectra of hydrogen. Then we need to tell which transitions lies in the visible region. So let me show you the line spectra first. So here you can see student, this is the electron transitions or the line spectra of hydrogen. So whenever the transition is from any higher state to the first shell, that is n equal to 1, that's your Lyman series which lies in the UV region. Okay, so this transition lies in the UV region. Then it is Balmer from higher higher transition state to the second one. So this Balmer series is the one which lies in the visible region. Then we have Paschen, Brackett and P fund is also there. All right, so these series lie in the infrared or higher infrared region. So basically you must know ki in which series, or you can say in which range these transitions will lie. So the question is about the visible range or the visible region. So it is the Balmer series. Okay, it's Balmer. I think it's not written correctly. So it's Balmer series. So the answer is going to be option B. Okay. Next question students, it says for which of the following the Bohr model is not valid. So you know that Bohr gave his atomic model for the hydrogen atom. Now how much electrons hydrogen is having? Hydrogen is having 1 electron. Okay, so not just for the hydrogen atom, Bohr's model is valid for those atoms also which are hydrogen like. Okay, you can say hydrogen like. Now what does hydrogen like means? Hydrogen like means the ones that are having 1 electron or the 1 electron system. So they will be so the Bohr's model will be valid for the 1 electron system. If I talk about the helium ion He plus, so helium is having 2 electrons, so He plus will be having 1 electron. Similarly deuteron atom, deuteron is just an isotope of hydrogen. Okay, so its atomic number is 1 and mass number is 2. So again it is 1 electron system only, and hydrogen is also 1 electron. So we have singly ionized neon atom, so it will be having 9 electrons. So in this case the Bohr's system or the Bohr's model will not be valid, because you have to keep in mind that the Bohr's atomic model was just valid for your a 1 electron system, means hydrogen and hydrogen like species. So the answer is going to be option number B. Okay. So students, this is our next question now. It says match the list 1 with list 2. So this question is talking about the quantum number. So we have studied about the quantum mechanical model of the atom, and there are 4 quantum numbers that we have studied. The principal quantum number, azimuthal quantum number, magnetic quantum number, and the spin quantum number. Okay, now what is the information that these quantum number provides us? That is the question all about. So for that, we need to know a little bit in detail about the quantum numbers. Let's revise that. So first of all, we have the principal quantum number, which is denoted by n. Okay, so this principal quantum number, it is actually telling us about the shell, कि the electron is lying in which shell. So the information about the shell we get from the principal quantum number, and that shell means we get to know about the distance of electron from the nucleus. Means for first shell the distance will be less, for second it will be more, for third it will be further more than that. So we get to know about the distance of the electron from the nucleus. So you know that the n values, like if it is 1, 2, 3, 4 and so on, it corresponds to the shell K, L, M, N. So we get to know about the distance of the electron from nucleus with the help of our principal quantum number. That is actually the main quantum number that we have. So here the n is given, alright. So that we will be seeing. So distance of nucleus means we can get the idea about the size of the orbital or the size of the atom. Ki what will be the size, because more the number of shells, more will be the size. Alright, so for D it will be second, that is the size of the orbital. Okay, now next is the azimuthal quantum number. Now azimuthal quantum number is denoted by L. Now for every value of n, there are zeros se lekar up to L minus 1, sorry, n minus 1 values of L. Okay, so let's say if n ki value is 1, so the value of L will be only 0. Now this L0 corresponds to the s orbital. And you know that these s, p, d, f orbitals have different shape. S orbitals are spherical, p are double shaped, d are double shaped. Okay, so L0 denotes the s orbital. Similarly, if I am having n equal to 2, means if I am talking about the second shell. Now this second shell will be having two values, L equal to 0 and L equal to 1. So means it will be having one s, means s orbital will be there and p orbital would be there. So L equal to 1 denotes the p orbital that we are having. Alright. Now next up is L equal to 2. Like if n is 3, so L ki values will be 0, 1, 2. Right. So L equal to 2 denotes the d orbital. Similarly, L equal to 3 denotes f orbital and so on. So we get to know our electron is in which orbital inside the shell. Okay, we get to know about the shell from the principal quantum number. Then we get to know about the orbital from the azimuthal quantum number. And if I get to know about the orbital, we can get to know about the shape, because different orbitals have different shape. Like S has spherical shape, just now I told you. Okay, so the azimuthal quantum numbers let us know about the shape of orbital. So this will be the right one. Now let us come to the next one, which is magnetic quantum number. Okay, now these orbitals have different orientation in space. Alright, so if we get to know about the orientation of the orbital, so that will be told to us by the magnetic quantum number. Now for every value of L, okay, we can say that for every L there are 2L plus 1 M values. Means कि कितनी orientation होंगी, that will be denoted by 2L plus 1. For example, if L is equal to 0, means I am talking about the s orbital. Okay, this is important, students, you need to know that. So if I am talking about the s orbital, so it will be having how many values? Only just one value of m, means only one orientation, because it is spherical. So spherical के लिए तो only one orientation would be there, right? And the values vary from minus L to plus L. Okay, so similarly here if I talk about L equal to 1, let's say if I'm talking about the p orbital. So p orbital के लिए how many orientations would be there? 2 into 1 plus 1, that is total 3. So 3 orientation means जो m की value होंगी, m l से भी हम इसको denote करते हैं, it will be -1, like from -l to +l ना, so 0 and 1. So you know कि there are 3 type of p orbitals, px, py and pz, that are oriented in 3 different directions, x, y and z. Okay. Then if I talk about L equal to 2, so that is our d orbital. So that will be having 5 values. Okay, ml ki there will be 5 values, -2, then -1, 0, +1, +2. So you have these 5 orbitals, dxy, dyz, dzx, right? Then we have dx square minus y square and dz square. So see, we are getting to know about the orientation of the orbital from the magnetic quantum number. So yes, we are having this thing. So orientation of orbital. So this is there. Ms is left. Now Ms, I'll tell you, Ms is the spin quantum number. Okay. Spin quantum number. Now whenever an electron, so you know in a particular orbital, so like if we are having this, so let's say if this is px, py, pz. So if there are 2 electrons now, so those 2 electrons can be arranged like clockwise and anti-clockwise. See, from spin quantum number we get to know about the spin of the electron. Spin of the electron means whether it is clockwise or anti-clockwise. Okay, so we get to know about the spin of the electron from the spin quantum number. Let's say if the electron is revolving clockwise or whether it is revolving anti-clockwise. Just like the earth, earth revolves around the sun, but it revolves on its own axis. In the same way, electrons also revolving around the nucleus, but they are revolving around their own axis as well. Okay, so that is determined by the spin quantum number ms. So ms के लिए there are always 2 values, +½ for clockwise spin and -½ for anti-clockwise. So there can only be 2 values for the spin quantum number. So if we look at the answer, students, for A it's 3. Okay, A 3. We have 2 options. Then for B it's 4. Okay, again 2 option. Then C के लिए it's 1 and D 2. So yes, the answer is going to be option number 4. This will be the correct answer. Okay, so this question was based on your quantum numbers. I hope you have understood that. Now let's move on to the next topic and the next question. So students, this is our next question. It says 4d, 5p, 5f and 6p orbitals are arranged in order of decreasing energy. The correct option is, okay. So here there are different orbitals given to us. Okay, we need to arrange them in decreasing order of the energy. So before we solve this question, there are 3 rules that we need to understand that are required for writing the electronic configuration of any element. Okay. Because now we have understood about the quantum mechanical model, we have understood about the quantum number. So it is important for us to know about how to write the electronic configuration. So there are 3 rules that govern that. The first one is Aufbau's principle. Okay. Now Aufbau's principle says that the electron will occupy the orbitals having lower energy before occupying the higher energy orbitals. Okay. It means that the lower energy orbitals will be filled first and higher energy orbitals will be filled only after them. Now, how are we going to decide ki which one is having lower energy and which one is having higher energy, right? So in that case, we have this n plus L rule. Okay, so the orbital having lower value of n plus L will be having lower energy. Okay, and the one having higher value will have higher energy. Okay, but if there is n plus L, if the sum is same for 2 orbitals, so the one having lower value of n will be having lower energy. In that order we will be doing it. Okay, so this is how the orbitals are filled. Now we have 1s, 2s, 3s. Okay, so this chart you can draw. Even if you don't remember this chart, you just remember this n plus L rule. Okay, like for 1s, the value of n is 1 and value of L is 0. So n plus L becomes 1. So this 1s orbital has the lowest energy. After that we have 2s. Okay, now after 2s, 2p will come or 3s will come, that we have to see. So let's see 2p. 2p के लिए n is 2 and l is 1. So n plus l की value will be 3 for 2p orbital. Now let's see for the 3s orbital. So n is 3 and l is equal to 0. Now same rule comes here, n plus l is 3. Now the value is 3. That is same for both of them. Now I told you that if the value of n plus l comes out to be same, then the one having lower value of n will have lower energy. So यहाँ पर the value of n is lower, which is 2. So 2s के बाद 2p orbital will come. After that 3s, then 3p. Same goes with then. Now 3D. Now we have 3D. Now someone will think, ma'am, 3D will come before 4s. No. Now what happens is, if I look at 4s, the value of n plus l will be 4 plus 0, which is 4. Then if I look at the 3D orbital, okay. So for 3D it's 3 plus 2. क्योंकि D के लिए L is 2 ना, so it's 5. Now you see that 4s will be having lower energy than the 3D orbital. So 4s, if we are filling the electrons, so 4s orbital will be filled first before the 3D. Okay. So this is the Aufbau's principle that we have to use for filling the energy levels, like for filling the orbitals. So we can apply this concept to solve that particular question. So that question was asked on Aufbau's principle. Maybe this year they can ask on Pauli's exclusion principle or Hund's rule. So we need to know about them as well. So we have studied, students, that Pauli's exclusion principle states that a maximum of 2 electrons, each having opposite spin, can fit in an orbital. Now this is also important. It says no 2 electrons in the same atom can have the same values of all 4 quantum number. Okay, means एक atom के अंदर no 2 electrons can have same values of all 4 quantum numbers. Let me give you an example. Okay, so having a 2p orbital. Okay, 2p orbital में there are these electrons. Okay. Now if I talk about this electron which are present in 2p orbital, can you write down the quantum numbers for that? Yes. So the value of n is equal to 2 for these 2 electrons. Okay, for electron 1 and for electron 2. N is 2. Okay, the value of L, since it's in p orbital, the value of L is 1. Okay, now both of them are in px orbital. Okay, so means the value of ml, let's say it's -1. Okay, -1, 0 and +1 होते ना. So ml is -1. Now the 3 quantum numbers are same. According to Pauli's exclusion principle, 4th quantum number cannot be same, and 4th quantum number is the spin quantum number, right? So it means if the spin of one electron is +½ so in that case the spin of other electron has to be -½ means whenever you are filling the electrons, okay, both the electrons cannot have the same spin. This is wrong. Okay, clockwise, anti-clockwise. If one is clockwise, other has to be anti-clockwise. A maximum of 2 electrons we can put. So see, that's the meaning ki 4 quantum numbers cannot be same. 3 although they are same, but 4th has to be different. If one is having a clockwise spin, other one has to have an anti-clockwise spin. Okay, that's what Pauli's exclusion principle is saying. That's what it is saying. See, if the principal, azimuthal and magnetic quantum numbers are same, they must have opposite spins, right? That's the example that we have just discussed. Okay, next. Hund's rule. Hund's rule says it actually tells us about the order in which electrons are filled in the orbitals belonging to a subshell. So it says that every orbital in a subshell is singly occupied by electrons before a second orbital is filled. Again, that is very simple. If let's say I have p subshell and I have to fill 5 electrons in it. Okay, let's say I am having 4. Okay, 4 में easily समझ आएगा. So let's say I'm filling 4 electrons in it. So how you are going to fill 4 electrons? Will you do like this? 1, 2, 3, 4. In that case, one orbital remains empty. So that is wrong. So Hund's rule says that pairing will not start until all the orbitals have got one electron each, because these orbitals are of equal energy, they are degenerate. Okay, px, py, pz, these orbitals in case of p, they are degenerate. So all of them will get one electron first, like this, 1, 2, 3. Then now you can put the electrons, so like 4 and then 5 and 6. So this will be the correct order in which we are going to put the electrons. Okay. So see here, and in order to maximize the total spin, electrons in the orbital that contain one electron will have the same spin. Mean like if they are all having clockwise, so we will first fill all the clockwise, then anti-clockwise. Okay. So see, this is the correct way of filling the electrons. Like for 2p2, if I have to fill 2p2 also, so both the electrons will go like this, and I cannot put like this ki yahan par dono I have put it together. This is wrong. Okay. So this is how, students, the electrons are filled. Okay. So these three rules are very important to understand the electronic configuration. Now let's see the question. So we have 4d, 5p, 5f and 6p. So from here, now let's say if you don't remember the chart, so you will remember the n plus l rule. So just find out the values. So it's here 4 plus, so l ki value you know 0, 1, 2, 3, s, p, d, f. So for d it's 2. So right here 6 and 5 plus 1, again 6. Okay, then 5 plus 3, it's 8, and then 6 plus 1, okay, it's 7. So obviously the one having highest energy would be 5f, because the value of n plus l is 8. So 5f is having the highest energy. Then obviously 6p will be there. Now tell me, out of 5p and 4d, which one will come? Because both of them have same values, so one having lower value of n will have lower energy, means first 5p will come and then 4d will come. So this is going to be the correct order: 5f, 6p, 5p and 4d. That is your option A. So students, with that we have revised many questions of this chapter related to different topics. Okay, so these are the important topics that you need to revise. So if you want to practice more PYQs, so you can refer to the MemoNeet PYQ book. So you can order your own version of the books. Alright, you will be getting all the questions in one place, chapter wise. And yes, like I have already told you, to practice the line by line NCERT questions on the MemoNeet app, because mostly you can see the questions are directly asked from the NCERT lines. So if you practice all the questions of NCERT, so no one is going to stop you from achieving your dream score. Okay, so in that case, go on the MemoNeet app. There is a option of line by line NCERT. So there you will get a lot of numericals and all the relevant problems, like all the relevant questions related to a particular chapter. So once you watch this video, go and practice those questions. Okay, then complete this chapter for BPT 6. Then we will be moving on to the next chapter. So yes, in case you are having any doubts or any questions, I asked you to tell me in the last video also that if you want me to make a video on any particular topic, so we will be doing that for you. So you just comment in the comment section that ma'am, this topic or this question is not clear, so we will be helping you out. Okay, and don't forget to like and share this video with all your NEET aspirants, all your friends, okay, who are preparing for NEET exam, because if you think it will be useful for them for their preparation. Okay everyone, so we will be meeting in the next video. Until then, take care. Bye bye.